All right, welcome to the second video in lesson 35. Lesson 35, again, the topic is changing coordinates and the distance formula, and this video is going to focus just on the short topic of the distance formula. All right, so example 3 here, this is topic number, or letter C on this in this section. Real quick example, just says find the distance between -4 and 2, 7. I recommend you take a moment, pause the video if you have to, plot the 2 points on a graph, and connect the dots in the way that I've shown. And what we're trying to do is we're trying to find the distance between the 2 dots. Very simply put, the distance formula, I've got it written over here in red. I've already given you the punchline because this is review, is something that you would have done in your Algebra 2 class. Distance formula is basically an adjusted form of the Pythagorean theorem. So if I were to take this equation, this set of points and connect them together into a triangle, I would get a right triangle where the bottom piece, the base, if you would, is the difference between the 2 x-coordinates, where the x-coordinates are, and when we say difference between, we mean the change in x, where the 2 x-coordinates are x2 minus x1. And if we subtract those 2 x-coordinates, it's 2, because that's our second x-coordinate, minus -4. So 2 minus -4, which gives us 2 plus 4, or 6. So the difference in the 2 x-coordinates is 6. And then the difference in the 2 y-coordinates, that would be this distance, would be change in y, which is, y2 minus y1, and the y2 is 7, and the y1 is -4. So 7 minus -4, which gives us 7 plus 4, or 11. All right. Well, it's a right triangle, so the bottom side squared plus the top side squared equals plus the vertical side, this leg squared plus this leg squared equals the hypotenuse squared, d squared. So that formula is shown here. We just simply said that the bottom is the change in x. It's x2 minus x1, and if I square it, it looks like this, x2 minus x1 squared. And then the vertical side is y2 minus y1. y2 minus y1. And if I square it, it's y2 minus y1 squared. So the sum of those two have to equal d squared. So if I want the distance, I would simply take the square root of both sides, which is what you see here in this red formula. All right? So the distance formula is shown here in red. I highly recommend that you memorize this formula as soon as possible, if you haven't already. All right, so to clean this up and simplify it then, for my particular problem, the distance is equal to, again, the square root of what we've already done, which was 2 minus -4 squared plus, and that was the change in x. I'm missing a parentheses on this. Plus 7 minus -4 squared, which was the change in y. Of course, we already did that math, and so this is the square root of 6 squared, that was the x, plus 11 squared, that was the y. And of course, this is the square root of 36 plus 121, which is equal to the square root of, 157. And the square root of 157 is an approximate value, approximately 12.53. So the distance between these 2 points is approximately 12.53. Honestly, I would prefer that we just leave the radical value. All right, distance formula, very, very simple. You simply take the difference in the 2 x-coordinates and square them. And to be honest with you, it doesn't matter what order you put them in because you're going to square it and get the same value anyway. And then you subtract from that the difference of the 2 y-coordinates squared. All right, that concludes the distance formula. That is the end of section 35. You hopefully got something out of this and you can start your homework.